Factories A and B sent rice to stores 1 and 2. A sent 11 loads and B sent 24. Store 1 received 18 loads and Store 2 received 17. It cost $200 to ship from A to 1, $350 from A to 2, $300 from B to 1, and $250 from B to 2. $8,550 was spent. How many loads went where? So let's take a look at this problem, and I'm going to draw just a little table to kind of organize everything because we got a lot going on here. We have a Store 1 and we have a Store 2, and I kind of line them up because the question was know how many loads went where. So we want to know where, how much went to each store. So those are going to become my variables. Actually, we'll have several variables here because of the different things we're being asked for. And then we have Factory A. So I'm going to do Factory A, and then we have Factory B. So let's see what we have here. And I'm going to go ahead and label because the question says A sent 11 loads and B sent 24 loads. So let's just look at Factory A together, and this will be a total. Let me get over here. So this is the total load sent from each factory. Okay. Store 1 received a total of 18 loads, and we'll come back and fill in our variables. And then Store 2 received a total of 17 loads. Okay. So in our boxes here, we're going to have different variables. And you can actually kind of do your variables. I could have done X, Y, and then ZW, but just make sure you remember which one's which when you, or what variable is standing for what. So what I have here is from Factory A, X is the number of loads sent from Factory A to Store 1. Y is the number of loads from Factory A to Store 2. And remember, when we add those two together, we get 11. Z is the number of loads from Factory B to Store 1. And then W is the number of loads from Factory B to Store 2 because, again, I want to know how many loads went where. And this is going to help us find it. And we have just a little bit more information. We know the cost. And let me just erase. I kind of got a little crazy here. So we can read it. Alright, it costs $200 to ship from A to 1. Now remember, from A to 1 is my X variable. So it's $200 times whatever that is. So I would write that as 200x plus, because we are given a total. So we're going to add a bunch of stuff together, or a few things here together, I should say, and it's going to equal $8,550 because that's how much was spent. So $200 for the loads from A to 1, $350 from A to 2, which is Y, $300 from B to 1, Z, and then the last one is $250 from B to 2, which would be $250 times W. Okay. So now we're going to have several equations here, and we're going to have to solve these, and we're going to do it using a matrix and a calculator. So let's get to a clean page here. So remember what your chart was. Hopefully you wrote it down so you can refer back to it. If not, go ahead and pause this and go back and write down the chart so you can kind of see where our equations are coming from. So I'm going to go ahead and rewrite that first one, which was the cost for each load, or for the loads. And again, you can use different variables. You just have to remember what each variable stands for. So that's important. Okay, so there's our first equation. And then remember, we had the total number of loads sent by factory A, and that was x plus y equals 11. And then we had the number of loads that factory B sent, which was 24. And remember, the variables we used was z plus w equals 24. And you notice I'm lining these up. And then what else do we know? Well, we also know how many loads each store received. So store 1 received 18 loads. So that would have been load the x plus z, and that equals 18. And then the other one would be from store 2, and those loads equaled 17. So that would be y plus w equals 17. So we have 5 equations that we're going to have to write in an augmented matrix and then put it in our calculator and do a reduced row echelon function to solve these. So what is this going to look like as an augmented matrix? Well, let's plug it in. So we had 200. And remember, augmented matrix, you just look at the coefficients. So we're going to write each one of these in so we can see what we have. So again, I hope you wrote the equations down so we can remember the other one was x plus y. So it'd be 1, 1, and then we didn't have a z, and we didn't have a w, and it equaled 11. Then we had z plus w equals 24, so that means there's no x, no y, z, w, and there's our 24. And then we had x plus z equals 18, so that's 1, no y, z, no w, 18. And then our last one was y plus w, so that'd be 0x, y, 0, 1, and 17. And I'm going to go ahead and extend my little brackets out just a little bit so we can, there we go. So there's our matrix. And now when you put this in your calculator, okay, so when you plug your matrix in and solve, you're going to get your answers. So the matrix, or the reduced row echelon of this matrix, ends up being 1, 0, 0, 0, 11, 0, 1, 0, 0, 0, 0, 0, 1, 0, 7, 0, 0, 0, 1, 1, 7, and then zeros all across the bottom. So what does that tell me? Well, remember, this was my x, y, z, and w, and this is our answer. So that tells me x equals 11. This one tells me y equals 0, z is 7, and w is 17. So that lets me know that 11 was from A to 1, 0 from A to 2, 7 from B to 1, and 17 from B to 2.